So imagine for a second that you're, I don't know, trying to figure out why a particular jazz symphony moves you to tears.
Right.
But instead of actually just listening to the music, you decide the best way to understand it is to take a hacksaw, cut the brass trumpets into tiny pieces, and measure their exact molecular weight under a microscope.
Yeah, I mean, you would walk away from that experiment knowing the precise atomic composition of brass, sure.
Exactly.
But you would be completely deaf to the jazz. You'd have all the individual pieces, but you'd completely miss the relationships between them, which is, where the music actually lives.
Well, welcome to the deep dive. Today, we are taking a look at a massive stack of sources, from modern computational biology to ancient metaphysics, that completely dismantle how we map reality.
It's a huge topic.
It is. And for those of you tuning in, just a quick note. We are entirely bypassing the tired, over-debated atheism versus theism arguments today.
Oh, yeah, completely.
That binary just traps us in a very, very limited way of thinking about the cosmos. So we're focusing on something much more profound. It's a concept that sources refer to as the cybernetic logos.
Which is such a great term.
Right. It's basically the realization that reality is not a static, top-down pyramid. It is a vibrant, deeply interconnected web. And we're going to explore the exact frameworks that scientists and philosophers use to describe it.
And this really represents a fundamental shift in human perspective. We're moving away from looking at reality as a collection of isolated, static objects just bouncing off each other.
Like billiard balls.
Exactly. And instead, we're understanding it as a network of dynamic, ongoing processes. Once you make that shift, once you stop looking at the gears and start looking at the flow of the machine, it changes how you understand literally everything around you.
Okay, let's unpack this a bit, because before we get into the specific taxonomies of this web, I feel like we need to understand what we're replacing. Why did classical science struggle so much with complex reality? What is the actual problem with taking a hacksaw to the trumpet?
Right. Well, the problem is a methodological trap called reductionist scientism.
Scientism?
Yeah. So classical Newtonian mechanics, the physics that gave us the Industrial Revolution, it operates on this idea of isolating discrete physical variables. You look for linear, one-way causality.
So object A strikes object B, causing it to move.
Exactly. It's very intuitive. And for simple mechanics, I mean, it's brilliant. The issue arises when scientism becomes a dogma.
When it's the only way we're allowed to look at things.
Right. The belief that this reductionist empirical observation is the only valid way to measure objective truth. It assumes that macroscopic phenomena like a living forest ecosystem or, human consciousness are nothing more than just the linear sum of their microscopic parts.
Meaning, if I just understand all the individual neurons, I automatically understand the subjective experience of falling in love.
Yeah, which obviously doesn't work. It treats the universe like a disassembled pocket watch scattered on a table.
That analogy captures the flaw perfectly.
It does, because here is where that reductionist approach structurally breaks down. It fails entirely when you try to model nonlinear systems or biological self-maintenance or adaptation.
Like a living organism.
Exactly. Think about a living cell. If you isolate a cell completely from its environment to study it as a discrete, independent variable,
it dies.
Right? The cell simply dies. A living system is its continuous interaction with its environment. It maintains its state by constantly exchanging energy and information.
So by isolating it, you destroy the very thing you're trying to study.
Exactly. Mechanical empiricism just completely discards the exact relational dynamics and contextual feedback loops that generate life in the first place.
I'm struggling with this a bit, though. I understand why reductionism fails in biology. But when I look at the sources talking about general systems theory, this movement in the 20th century, to map these complex dynamics, they claim this is somehow a validation of ancient metaphysics.
It's a fascinating connection.
Yeah. But are we really trying to say modern computational math is just ancient Greek philosophy in a lab coat? Because that feels like a massive historical stretch to me.
Well, it sounds like a stretch until you look at what those ancient philosophers were actually describing. General systems theory, which was pioneered by thinkers like Ludwig von Bertalanffy, it genuinely functions as a mathematical reactivation of concepts that are thousands of years old.
Wait, really? Like what?
Take the ancient Greek concept of the logos, specifically how the philosopher Heraclitus or the later Stoics defined it. For centuries, modern audiences have misread the logos as some sort of anthropomorphic sky god issuing moral decrees from the clouds.
Which is where we get trapped in those atheism debates.
Yeah.
We end up arguing about a literal guy with a beard in the sky.
Right, exactly. But the Stoics weren't talking about a guy with a beard at all. Their concept of the logos grammaticos was the immanent rational code governing tension, change, and recursive balance in nature. Yeah, it was the underlying operating system of the universe. Systems theory takes that ancient intuition and just formalizes it mathematically. It shifts the metaphysical, primitive, the fundamental building block of reality away from static material substance.
And places it where?
It places it squarely on dynamic relation and information flow.
Hold on, let me make sure I'm mapping this correctly.
Yeah.
Moving from substance to relation.
Yeah.
How does that actually work mechanically?
Well, in a mechanical worldview, causality is a one-way street. But in a systems worldview, causality is circular. We are talking about cybernetic feedback loops.
Okay, circular causality.
Yeah. So you have negative feedback loops, which stabilize systems. Think of a thermostat.
Right.
It isn't just a simple switch, you know. It's a sensor detecting a deviation from a set temperature, which then triggers a heater to reduce that deviation.
Wow.
And once the baseline is reached, the sensor shuts the heater off.
So it's circular. It's constantly adjusting based on its own environment.
Exactly. And then you have positive feedback loops, which drive rapid adaptation or even collapse, like a microphone getting too close to a speaker.
Oh, where it picks up its own output and amplifies it until it screeches.
Right. The system is constantly reacting to its own output. And because of this continuous circular causality, you get what we call emergent properties.
Emergent properties. What are those exactly?
These are macro-level behaviors that absolutely cannot be predicted by looking at the isolated microcomponents.
Can you give an example of that?
Sure. You can study an isolated hydrogen atom and an isolated oxygen atom for 1,000 years, and you will never be able to predict the phenomenon of wetness.
Oh, wow. Yeah.
Wetness just doesn't exist in the atoms themselves. It emerges strictly from the relationship between them. The higher-order systemic structure actually exerts downward causation, basically organizing how the lower-level parts behave.
The whole literally changes the behavior of the parts.
Yeah.
That is wild to think about.
It really is.
But it brings up a practical problem.
Yeah.
If reality is just this cascading series of feedback loops and emergent processes, how do we even begin to talk about that scientifically?
We'll need the right words for it.
Exactly. For anyone listening who wants to explain this worldview to a colleague, we need an actual vocabulary that doesn't rely on mystical buzzwords. Are there rigorous frameworks for this?
Yes. What's fascinating here is that the sources provide a very precise taxonomy for this exact purpose. So the most direct, overarching counterpart to scientism is called systemism, or sometimes systemicism.
Systemism. Okay, that's clean. It does what it says on the tin.
Yeah, it simply asserts that reality is fundamentally composed of dynamic, interconnected systems, not isolated particles.
Yep.
But underneath that broad umbrella, you have specific disciplines depending on what aspect of the web you are studying.
Okay, so what's an example of one of those specific disciplines?
Well, there is cybernetism.
Cybernetism.
Yeah.
Which sounds incredibly sci-fi, I have to say.
It does, but it derives from Norbert Wiener, a mathematician in the 1940s. He was studying anti-aircraft guns during World War II, trying to figure out how a machine could predict the future location of an enemy plane.
Wow. Yeah.
And he realized that both machines and biological nervous systems use the exact same mechanism to navigate the world. Error-correcting feedback loops.
Just like the thermostat.
Exactly. So cybernetism focuses heavily on that information flow and how systems self-regulate across nature, technology, and the human mind.
Got it. So systemism is the broad ontology of interconnectedness, while cybernetism focuses specifically on the mechanics of feedback and information flow.
That's a great way to delineate them. Then you have relationalism, which is sometimes called processism, and this goes straight to the philosophical core.
How so?
It argues that dynamic processes and relations are more primary, more fundamentally real than static material substances.
Okay, wait. Can you ground that in a physical example? How can a process be more real than the stuff it's made of?
Think of a hurricane. We name hurricanes, we track them on radar, we treat them as distinct things. But a hurricane isn't a solid object.
Right, it's just weather.
It is a massive, self-organizing pattern of wind, water, and heat. The actual water molecules making up the hurricane are constantly flowing in and out of it. The physical matter changes completely from day to day, but the pattern maintains its form.
That makes total sense.
So relationalism argues that you, as a human being, are much more like a hurricane than a statue. Your cells regenerate, your atoms swap out, but your relational pattern persists. The universe isn't made of things, it's made of happenings.
Made of happenings that completely flips how you look at a tree or a city or even your own body.
It really does.
But if everything is just a happening, how do these happenings organize themselves without just falling into total chaos?
Well, that brings us to Holonism. It's a term coined by the writer Arthur Koestler. He created the word holon to describe an entity that is simultaneously a whole in itself and a part of a larger system.
Okay, like a single cardiac cell in my heart. The cell is a complete functioning system on its own,
Yep.
with its own metabolism and DNA.
Right.
But it's also just a tiny, dependent part of a larger system of my heart. And my heart is a whole system, but it's just a part of me.
Exactly. That nested structure is exactly what Koestler meant. Reality is framed as these emergent hierarchies across all scales, which leads to perhaps the most mathematically profound term in this taxonomy: recursive isomorphism.
Recursive isomorphism. Okay, you're going to have to translate that one for me. That sounds like something out of a graduate-level topology seminar.
I know, it's a dense term for a profoundly beautiful concept. It's the principle that self-similar rules and mathematical structures repeat themselves across radically different domains.
So patterns repeating everywhere.
Exactly. It's the reason why the branching pattern of a river delta from an aerial view looks identical to the branching pattern of blood vessels in your lungs, which looks identical to the dendritic networks of neurons in your brain.
Like the universe is beautifully lazy. It finds a mathematical rule that works for distributing resources, and it just copies and pastes it across biology, geology, and anatomy.
That's a brilliant way to put it. The exact same structural grammar is recursively copying itself across physical, cognitive, and even social scales.
Wow.
This is why having this vocabulary really matters for anyone trying to understand the world. When you intuitively feel that everything is connected, you aren't just having some poetic emotional reaction.
You're actually observing real structural law.
Exactly. You are observing recursive isomorphism. You are noticing relationalism. You are identifying the cybernetic logos. It bridges the gap between deep, conscious intuition and rigorous scientific structure.
I see where this gets complicated, though. Here's where it gets really interesting. Because if reality is this system of nested Holland cells to organs to bodies to ecosystems, that sounds suspiciously like a pyramid. And human beings love pyramids. We organize everything into military chains of command, corporate ladders, caste systems. Does systems theory suggest that the universe is just one massive top-down hierarchy?
Actually, it suggests the exact opposite. What's crucial to understand here is the anthropomorphic bias of hierarchy.
Meaning we're projecting our own stuff onto nature.
Precisely. Imposing a rigid, top-down dominant structure onto nature is a classic case of humans projecting their own cultural, social, and political biases onto reality. We assume that higher levels in a system must command or possess more inherent value than lower levels simply because that's how human empires and corporations operate.
Yeah, we project the idea of a CEO onto nature, assuming there has to be an executive in charge barking orders down the chain.
Exactly. But dynamic systems in the universe just don't function like that at all. The sources outline several alternative structural models that are far more accurate, and the first is heterarchy.
Heterarchy, as
Right.
opposed to hierarchy. So what does a heterarchy look like in practice?
You see heterarchies constantly in ecological food webs. In a heterarchy, authority and influence are contextual and distributed. Node A might constrain Node B in one specific situation, but in a totally different context, Node B constrains Node A.
Oh, fascinating. Give me an example of that mutual constraint.
Sure. Take a forest ecosystem. In one context, the chemical composition of the soil acts as the dominant constraint on the growth of the trees. It dictates what can survive.
Right, the soil is in charge.
But over time, the trees drop their leaves, their roots shift the earth, and their canopies provide shade, which completely transforms the chemical composition and moisture levels of the soil.
Ah, so now the trees are controlling the soil.
Exactly. They form adaptive mutual feedback loops rather than a fixed permanent pecking order.
It's a continuous negotiation, not a dictatorship. What's another model for this? Because I'm picturing something like the internet or, a massive fungal network beneath the forest floor.
Fungal networks are the perfect visual for the next concept, actually. Rhizomatic networks, which is drawn from philosophers Gilles Deleuze and Félix Guattari.
Rhizomatic networks.
Yeah. A rhizome in nature, like ginger root or crabgrass, operates very differently from a tree. A tree has a central trunk, right? If you chop the trunk, the whole organism dies. But a rhizomatic system has no central root and no vertical axis. Any point in the network can connect to any other point. It grows horizontally, organically, without any core command center.
which is exactly why crabgrass is so impossible to get rid of in a lawn. There is literally no head to cut off. It just distributes its processing and growth across the entire net.
Exactly. And when you zoom in on how living systems maintain themselves within these networks, you hit a concept formalized by biologists Humberto Maturana and Francisco Varela. It's called decentralized autopoiesis.
Okay, let's break that word down. Auto meaning self, poiesis meaning creation or poetry. Self-creation.
Yes, self-production. It describes the specific mechanical way living systems maintain their balance through distributed local feedback.
So how does that work?
Well, think about a biological cell. A cell isn't built on a factory assembly line where external machines put the pieces together. The cell synthesizes its own internal proteins, which then constantly rebuild the very lipid membrane that encapsulates the cell. The product of the system is the system itself.
The factory is basically building itself while it's operating.
And it does this entirely through lateral cooperation and reciprocal constraints. There is no central executive command center in an ecosystem telling the deer exactly how much grass to eat or the wolves how much to hunt.
Right.
The macro stability of the ecosystem emerges entirely from the lateral, bottom-up interactions of the parts acting autonomously.
It's self-arising order. And this is where the history completely blows my mind. Because if you read the ancient texts, this distributed, non-hierarchical network is exactly what they were trying to describe thousands of years ago, isn't it?
Oh, absolutely.
Long before Norbert Wiener was studying anti-aircraft guns, these ancient traditions were mapping out heterarchies.
The parallels are stunning. And if we connect this to the bigger picture, the sources highlight several ancient predecessors to these exact network models. In Hawaiian Buddhism, for example, there is the cosmological concept of Indra's net.
I remember seeing that reference in the sources, and it stopped me in my tracks. Because it sounded exactly like a modern holographic model of the universe, but written in antiquity. How does Indra's net map onto what we're talking about?
So Indra's net is visualized as an infinite, multidimensional web stretching across all space and time. And at every single vertex of this web, there is a multifaceted jewel.
Okay.
The key is that there is no central jewel. There is no primary node that dictates the rest. And because of the way the net is infinitely structured, the polished surface of every single jewel perfectly reflects the light of every other jewel in the entire net.
Every part contains the image of the whole. That is the ultimate metaphor for relationalism and recursive isomorphism. The macro is folded into the micro.
It is a profound formalization of complete mutual interpenetration, the idea that nothing exists independently, everything is constituted by its reflections of everything else.
That is just incredible.
And you see a similarly robust systemic mapping in the Taoist concept of Ziran.
Ziran. How does Taoism approach this differently than the Buddhist net?
Well, Ziran translates roughly to spontaneity or self-arising order, which maps beautifully onto the concept of decentralized autopoiesis we just talked about.
Okay, so it's that self-production idea.
Right. The foundational Taoist text, the Tao Te Ching, describes nature not as a manufactured machine that requires an external engineer, but as a self-generating, self-correcting field.
So how does the famous yin and yang symbol fit into that field? Is it just a metaphor for balance?
It's much more technical than just a poetic metaphor, actually. It is a qualitative representation of reciprocal feedback loops. Modern people often misinterpret yin and yang as a battle between good and evil, but it's really a cybernetic model.
Wait, really? A cybernetic model?
Yes. When yin reaches its absolute maximum, it inherently triggers the rise of yang. This represents negative feedback boundaries ensuring systemic balance.
Ah, I see.
Extremes systematically invert into their opposites, which prevents the system from experiencing a linear runaway collapse.
They basically mapped out homeostasis using philosophy instead of calculus. So what does this all mean? When you take a step back and look at this massive historical arc, from Indra's net and Ziran to modern cybernetics and systems theory, what is the ultimate takeaway for someone trying to make sense of the world today?
The core takeaway is that general systems theory is not just modern tech speak, and ancient metaphysics was not just naive superstition. Systems theory has effectively validated the intuitions of ancient metaphysics.
Right, they were seeing the same things.
Exactly. When those traditions talked about the logos or Indra's net or Ziran, they were not engaging in superstitious magic. They were conducting precise, systemic observations of reality's network architecture.
That is so cool.
They recognize that relations, information flow, and ongoing processes are the fundamental reality. Modern mathematics and computational biology have finally provided the conceptual grammar to prove they were right all along. Reductionist scientism, for all the technological progress it gave us, is simply an outdated paradigm for understanding complex reality.
It really is a complete paradigm shift. And it leaves me with a final provocative thought for you, the listener, to mull over as you go about your day. If reality fundamentally operates as a decentralized rhizomatic network,
Yeah.
if the universe is driven by lateral feedback, autopoiesis, and mutual adaptation, why do we continually try to build our artificial human systems as rigid top-down hierarchies?
That is the most pressing question we face regarding how we design our future.
Think about it. We build our economic structures, our artificial intelligence architectures, our corporate structures, and even our social media algorithms almost exclusively as top-down command and control pyramids.
Which goes completely against nature.
Right. So if our human designs inherently conflict with the cybernetic logos of the universe, if we are ignoring the basic mathematical laws of how complex systems actually thrive and self-correct, are we structurally programming our own systems to fail? Are we still just trying to weigh the brass of the trumpet while ignoring the symphony? It's something to think about. Thank you for joining us on this deep dive. Keep exploring the connections in your own world, and we'll catch you next time.